How's it going, guys? Today in this video, I want to go over those 9 extra problems that we gave you to work on. I'm going to go over them so you can actually have a little review before the quiz whenever you decide to take it, or whenever you are taking it. So in number 1, we have the cube root of 24 times a to the 11, b to the 6th. So what we're going to do here, or what I'm going to do, is I'm going to take the prime factorization of 24 first, just because there's no cube that gives me 24. So when I take the prime factorization of 24, or rather if I just break it up, I'll get 8 times 3 times a to the 11, b to the 6th. And 8 can be broken down into 2 cubed times 3 times a to the 11 times b to the 6th. So from here, there's 2 ways to go about it. We can use what our rules, our root property rules that we learned in 12.2, or we can just look for the groups of 3 that we can take out. So we're taking a cube root, so we're looking for groups of 3s of the same term to take out. So 2 cubed to the 3rd power, or 2 to the 3rd power cubed, right here we have 3 2's, so we can take out one group of 2's. So we take out one group of 2's, we have 1 2 on the outside. And we're left with the cube roots of 3 times a to the 11 times b to the 6th. Next, we have a to the 11. So we have 11 a's, so we can get a total of 3 groups of 3 a's, right? So how many terms we want in each group is determined by your roots. So we have a root of 3. So a to the 11, we can make 3 groups of 3 a's with 2 a's left over. So if you have 3 groups of a's, we can take out 3 a's. So we have a to the 3rd. And we're left with 3 times a squared times b to the 6th. And then for b to the 6th, we can make 2 groups of 3 b's. If we make 2 groups of 3 b's, that means we can take out 2 groups of b's. So we can take out 2 b's. So we have 2 times a to the 3rd times b squared, and what's left over is the cube roots of 3 times a squared. And that's going to be our answer for number 1. So you always want to look at how many groups of a term can I take out, and how many terms you want in that group will be determined by your roots. So in this case, we had a root of 3, so we want groups of 3 to take out. So for number 2, we have 16 to the 1/2, to the negative 1/2. So 16 to the negative 1/2. Anytime you have a negative exponent, all you want to do is flip it on the other side of the fraction. So 16 to the negative 1/2 is the same thing as 16 to the negative 1/2 all over 1. So we end up getting 1 all over 16 to the 1/2. 16 to the 1/2. That's the same thing as the square root of 16, which is 4. And that's going to be our answer for number 2, 1 to the 4th. And I do want to touch a bit about flipping negative exponents. So if we have 16 to the negative 1/2, we just flip it to the other side. But if we have something like a to the negative 3 times b to the negative 2, all over c to the negative 1, and d to the 5th. So this is a whole new problem. I just want to touch on flipping negative exponents. If we have a term like this, or a problem like this, all we want to do is take each term individually and just move it to the other side of the fraction. So the a is going to go to the bottom, the b is going to go to the bottom as well, and the c is going up on the top. So each thing moves independently. So the c goes to the top, so we have c to the 1st power, or just c. And that's going to be by itself, since a to the negative 3 goes to the bottom, so a to the 3rd times b squared, since the b went to the bottom, and the d didn't have to move, so it stays in the bottom as well. So everything, when you have a negative exponent and you're flipping it, it moves independently of all the other terms in the equation. So all you do is take the exponent, not the exponent, sorry, but that term, move it to the other side of the fraction, and change it from a negative to a positive. It doesn't affect anything else around it. You just move it from the top to the bottom or from the bottom to the top. So let's go on to number 3. On number 3, we have the cube root of 1 over 512. So the cube root of 1 all over 512. We can distribute this to say the cube root of 1 all over the cube root of 512. And once we distribute it, the cube root to the top and to the bottom, the cube root of 1 is just 1. The cube root of 512 is going to be 8. So our answer is 1 all over 8. That's just one of our properties. If you have the cube root of a fraction or of a quotient, you can distribute that root or that radical to the top and to the bottom. That's just the property that we use in this problem to be able to solve it out. Number 4, we have z to the negative 1/3. So z to the negative 1/3, like we talked about in a previous problem, if you have a negative exponent, all you do is flip it to the other side of the fraction. So this becomes 1 all over z to the 1/3. We can't simplify it anymore from here, or rather, we could and we should. I spoke a little too soon. We have z to the 1/3. So z to the 1/3 is going to give us a radical. Any rational exponent that has a fraction as an exponent is going to give us a radical when we rewrite it. And we don't want to have a radical in the bottom of a fraction. So we're going to rewrite this, or not rewrite it, but we're going to rationalize it to get rid of that exponent. So to do that, we're going to multiply it by some term that when we add the exponents, it becomes a whole number. Whether it's 1, 2, 3, 4, or 5, it doesn't matter as long as it's a whole number and not a fraction. And so when we're trying to multiply it, we're trying to figure out what we're going to multiply it with. We're going to multiply by the same base that it has, so z, and we're going to raise it to whatever power we'll add to the other exponent to give us a whole number. So in this case, 2/3. And that's because if we multiply this out, we get z to the 2/3 all over z to the 1/3 times z to the 2/3. And on the bottom, we have, we're multiplying two terms to the same base, so we add the exponents. So we end up getting z to the 2/3 all over z to the first power. And that's our problem rationalized. All right, so let's keep on going to number 5. On number 5, we have the 5th root of x to the 40, y to the 30, z to the 5th. So like we said before, that root, or whatever is in your index, which is 5 in this case, we're looking for groups of 5 to take out. So we have x to the 40, so we can take out 8 groups of 5 from x to the 40. We can take out 8 groups of 5x's, so when we take this out, we get x to the 8. Every group of 5 that we take out equals 1 of that term. We took out 8 groups of 5x's, so we have 8x's, or x to the 8. So that goes away. Now y to the 30, with 30 y's, we can create 6 groups of 5 y's. So we can create 6 groups of 5 y's. We can take out 6 groups of those 5 y's. So we have 6 y's on the outside, or just y to the 6th. And that goes away. And finally, z to the 5th, we can create 1 group of 5 z's. So we can take out 1 group of 5 z's, or just z. We have nothing left over inside the 5th root function, or the 5th root radical. So that's going to be our answer. We can't simplify it anymore from here. So that's what we're going to get. Number 6, we have 16 to the 7 over 4. So what we're going to do, we're going to solve this out. We have 16, 7 over 4. We can rewrite this as the 4th root of 16 all to the 7th power. And in this case, we're putting the exponent on the outside of the radical, and that's because we know what the 4th root of 16 is going to be. You could put it in the inside, but it's going to be a lot harder because you have to find 16 to the 7th power and then find the 4th root of that. It'll be much easier if you just find the 4th root of 16 and then raise it to the 7th power. So the 4th root of 16, that's going to give us 2, and we have 2 to the 7th power, and that gives us 128. So that was just much easier than putting the exponent inside, which is perfectly okay. You could do it, but it's just going to be a little harder. So knowing where to put your exponent, whether inside or outside, will help make the problem easier or harder. So let's keep on going to number 7. We have 100x to the 12 times, all raised to the 1/2. So there's 2 ways to go about it. I'm going to go about it both ways. So this is a product, 100 and x to the 12. So we can distribute this 1/2 to both terms. So we can have 100 to the 1/2 multiplied by x to the 12 to the 1/2. 100 to the 1/2 is the same thing as the square root of 100. And for x to the 12 raised to the 1/2, we can give a power to another power, and that's one of our property rules. So you have power to another power, you multiply them together. So we have 12 times 1/2, which is 6. 12 times 1/2 is just going to give us 6, so we have x to the 6th. And the square root of 100 is 10. So our answer is 10x to the 6th. The other way we can do this is just rewrite this as the square root of 100 x to the 12. And then from here, we can use our properties of roots, where we can rewrite this as the square root of 100 times the square root of x to the 12. The square root of 100 is 10, and the square root of x to the 12, with square roots, remember, that's the same thing as the second root. So we want groups of 2 to take out of x to the 12. So we can take out 6 groups of 2 x's out of x to the 12. So we take out 6 groups of 2 x's. We have 6 x's on the outside, or just x to the 6th. And that's the same thing that we got from the beginning. Either way works. You get the same problem. There's really no right way to start these problems. Just start somewhere and keep working with it using your properties that you know, and eventually you'll get to your simplified solution. All right, for number 8, we have negative 27 to the 2/3. So we have a negative coefficient, and that's perfectly okay. We do not need to flip it to the other side of the fraction. You only do that when you have a negative exponent. So negative 27 raised to the 2/3 is perfectly okay, and we can solve for it how we normally do. So we have we're raised to the 2/3, so we can rewrite this as the cube root of negative 27 all squared. And again, you could put the exponent inside the radical, and you'll still get the same answer. But finding the square of negative 27 and then finding the cube root of that will be much harder than just finding the cube root of negative 27, which we know what it is, and raising it to the 2nd power. So what I'm trying to say is this exponent can go inside or outside. It's perfectly okay either way. But depending on the problem, having it outside or inside will be easier depending on the problem. So anyway, let's go back to the problem. We have the third root, or the cube root of negative 27, which is negative 3. And it's all raised to the 2nd power. And negative 3 squared is just going to be 9. And that's our solution. Now for number 9, the last problem that we have f of x equals the square root of 7x plus 29. And we want to know what f of 1 is going to be. So we want to know what our function will be when x equals 1. So f of 1 will equal the square root of 7 times 1 plus 29. Or we can just say 7 plus 29, which is the square root of 36, which is 6. And that's going to be our solution. So I just wanted to quickly go over the 9 problems that we did assign you. It will be a good review for the quiz. And hopefully this helped, guys.